Today we're going to do 2.7, proving segment relationships. So this is building off of what we did last week with starting our two-column proofs with our algebraic proofs, solving for x and all of that. The only difference here is we're going to be using segments, and then the next lesson we'll be using angles. Still two-column proofs, so statements on the left, reasons on the right, and we number both columns. These postulates are very important, and so we have this ruler postulate that says any line or segment, we can measure it, right? You know this, we've done this. Here's one we've also done, which is very, very important, which is, we called it the segment addition postulate, and or betweenus of points, right? And so this is where we said AB plus BC equals AC. It's our betweenus of points. I told you we'd also call it segment addition. For proofs, a lot of times we'll call it segment addition postulate. Either way is fine, but make sure you know how to write those, okay? And then, of course, mark your givens. Gotta mark your givens. Now, you need to be taking notes with me, but this way you can pause it and rewind if you have any questions. We're going to start with example 1, and we have a figure here. If it doesn't have one, you should draw one. It says prove that segment AB is congruent to segment AD, then AC is congruent to BD. Well, it gives us this, so I just need to fill in my given. Remember, you have to start with what you know, and it already told me it was a given. Now, I'm going to come to the side and make a note for you before we go any farther, and that is based off this congruence. We talked a little bit about it this week, and I want to actually, last week, I want to actually write it out for you. Anytime you have something that is congruent, and you want to swap to equal, or anytime you have something equal that you want to swap to congruent, it doesn't matter which way you go, it is called definition of congruent. In this case, segments. Later we'll be doing angles. Because what's important is if you're going to plug in numbers, you can't plug in numbers or plug into an equation until you have it as an equal sign. So we have to make sure that if we're going to start working with an equation, we have an equal sign. It seems silly, but remember I told you names are congruent. Their measures are equal. So we're going to work with their measures. So here you can see the differences. We dropped our segment bars and dropped our congruent side, which means we're changing from congruent to equal. And anytime I'm changing from congruent to equal, it's the definition of congruent, in this case, segments. Seems silly, but it's an easy one to remember, and it's very important. Now, I look back up here, and always keep your end in mind, kind of see what you're trying to, where you're trying to go, and I'm going to mark my given. So it told me AB was congruent to CD, so I know those two are congruent. Now, we're going to have to talk about BC, and we haven't yet. So this is where we're going to basically introduce BC. Because it wasn't in my given, I need to introduce it. In order to introduce it, we're just going to use the reflexive property and say, hey, BC is equal to BC. Well, duh, of course it's equal to itself. It wouldn't be equal to anything else. But this way we can just formally introduce it into our two-column proof here. Remember, two-column proofs are really formal. Now, it tells us we want to do segment addition. Here's a hint for you. Your segment addition, well, I could use the whole thing here, but I know I'm going to want to prove something about AC and about BD. So it is really handy if I can write my segment addition for AC and for BD. So I'm going to first write a segment, and it doesn't matter what order. I'm just going to write it for AC first. So for AC, AB plus BC equals AC. So AB plus BC equals AC. Now, before I go any farther, it tells me, hey, let's substitute something. Well, I know BC is equal to BC, but substituting that won't help. But here I also know AB is equal to CD. Substituting that will help. So I see AB. You know you're going to have to, if it says substitute, you have to substitute something above, and that's the only thing I have left. So I'm going to say CD plus BC equals AC, simple substitution. If you can follow directions, you got this. Next, we're going to do segment addition postulate. We're going to do it in blue this time. So remember, we wanted to say something about AC because we know we're going to have to use it at the end. Now let's say something about BD because we're going to use it at the end. So I'm going to say BC plus CD equals BD. Okay, here, if you'll look, which hopefully you see this before it tells you to use transitive, but notice I have CD and BC. Here I have BC and CD. Are those the same thing? Absolutely. They're equal to each other, so I can cut out that middleman and set the other two equal using either a transitive property. Remember, that's the same thing as syllogism if you prefer to use that. And then lastly, remember, proofs are really formal. You have to have them written the exact same way it tells you to, not the order swapped or anything. Well, in this case, it told me I had to prove that AC is congruent to BD. We have it equal, so our last step is to swap over to congruent. Okay, remember, you can email me with questions. You can come see me, but definitely be filling in your notes, and this will start to sink in. Okay, I want you to pause it and work this check your progress to yourself, and then I'm going to work it with you. Okay, you're only missing one step, so I want you to pause it and work that now. Okay, so if you looked at this problem, hopefully you've worked it. It looks a little crazy. I got a lot of segments going on here, but make sure, remember that mark your given. Okay, so we're going to scroll down here and mark our givens. AC is equal to AB. And then AB is equal to BX. Okay, so it also gives us something else, but I'm going to stop right there real quick. If AC is equal to AB and AB is equal to BX, you can cut out that middleman using that transitive property and set the other two equal. That's our first step. Then it gives us our other given. Now, no, these givens weren't get two here, one here. You can split them up. That's totally fine. You don't have to. You could have said them all in the first string, whatever you prefer. It also tells us CY is congruent to XD. So I marked that on my figure. And then it says additive property. So what it did was I have CY here and XD here. I had something added to each side. Well, whatever you add to one side, you can do to the other, but they're equal. So we added an AC over here and a BX over here because we add the same thing to both sides because they're equal. That might have been a little tricky. You might not have known how to do that, and that's totally okay. That's why we're practicing this together. Now look at 5. It says AY is equal to AC plus CY. And then it tells you BD is equal to BX plus XD. What are those? Well, that's our two small added up to the big. So that is our segment addition postulate. And then lastly, because we have, you can see that this is that and that's that. You can use transitive or substitution. Either one works here. Again, to see that what we're trying to prove is if that's equal to that and that's equal to that, then those switches last step. Awesome. Let's do another. Okay, so we talked about our reflexive property. Same thing on both sides, right? When Whitney looks in the mirror, Whitney sees Whitney. Symmetric property, this is where you swap. And then transitive, where you cut out the middleman, set them equal. This is just a reminder, but it works with congruent as well. You don't have to swap it over to equal. Okay, let's do another one. Okay, so you can read at the top, and it gives us some information here, and it marks it on the picture, so definitely pause and read that now. And then you can, it already has our givens filled in, one of them. Now it has the two other filled in down here. So I have a couple things congruent here and this one equal. That should be kind of a red flag there. Let's do something with that. How do we swap it over from congruent to equal? Well, remember, segments are always congruent, which means I should have my segment bar. The measure is what's equal. But whether I'm going from congruent to equal or equal to congruent, it's definition of congruent segments. We were dealing with angles, it'd be angles. Then I use my other two givens. Now I have these three statements, they're all congruent. And remember, you gotta kind of work with this end in mind. I'm trying to prove that this is equal to that. Okay, so let's see what we can do here. there's a couple different things. If I look straight above here, I see xz and xc. I can cut those out and set the other two equal. And you know that to be transitive property or law syllogism. But I also have, so that's good. This is one I'm trying to prove at the bottom, but I also have yz and yz that I see are the same. So I can cut those out and set the other two equal in transitive again. Now, if I write it like this, did I prove what it asked me to prove? No. Remember, proofs are very formal. They have to be written the same way. You might have already saw that, and so you swapped it and said wx is congruent to wy. That's great. You're finished. I didn't, so I'm going to need to add a sixth step to get it in the order that it wants it in, because remember, that's formal and it's very important. And that is going to be, we swapped it, so it's our symmetric property. Okay, good. Now, I want you to pause right here, fill in this, check your progress, mark your givens, fill in all the steps and then this last reason, and then start it back up to check your answers. Okay, so hopefully at this point you've already paused it, worked it, and started it back. It gives me my givens. I'm going to go ahead and mark them. GD is congruent to BC, and it tells me BC. So this one is congruent to FH. So we see something that's going to happen there, right? We can use our transitive property. And then FH is congruent to AE, which, sorry, I kind of covered up that A. It's right there. So we got all of this kind of going on, and we want to prove AE is congruent to GD. We can see in our diagram that is, so we just need to fill in the formal proof. Okay, transitive property. I see two BCs I can cancel. Remember, to plug into a formula, you're going to need them in equal signs, but you can do transitive, symmetric, or reflexive just with congruent. Oh, look, FH, FH. See how it's only introducing the given as we need it? Like I said, you can introduce them all at the top, or you can introduce them as you go. I prefer to just introduce the ones I'm using and then use them and then introduce my next given. That way I don't have too much going on. And then this is not how it wanted it. It wanted it like this. So this would be, again, I need to swap it with my symmetric property. Hopefully you got that all right, no problem. Great job. And we're done for the day. The big things to remember is that reflexive is the same on both sides. So something like this, and that's, if it's not in our given, that's how we introduce a statement. And then symmetric is where we swap it. So if it told me, this was the last lesson, x equals 7, but I actually had 7 equals x, I would have to swap it. Today we had something similar. And then of course your transitive is where you cut out the two that are in common and set the other two equal. And then the other big thing was this definition of congruent segments. So whether you're swapping from congruent to equal or equal to congruent, definition of congruent segments, like I said, tomorrow that'll be definition of congruent angles. It's a really simple thing, but sometimes it's hard to remember when to do it. If you're going to plug into a formula, you're going to need it to be equal. If you're going to, so for segment addition postulate, up here, you're going to need it to be equal. So when you do your segment addition postulates, those should always be equal, so you should have swapped the congruent to equal first. Awesome job, do your homework, and come see me if you have any questions. You can rewatch this video if it helps. Great job.